Hello, everyone. Welcome to today's webinar titled Exterior Tile Installation. I'm Jim Olson with the National Tile Contractors Association, and I want to welcome you for taking the time out of your day. Thank you for taking the time out of your day to, to just see what we have to offer today and see what our presentation is about. I know you all have busy schedules and it's always hard to attend, but thank you. Today's webinar is sponsored by Custom Building Products. Very excited to see this. It's going to be a good one. Like I said, exterior tile installation, which is a very touchy subject. So that's great. Now, before I introduce today's speaker, I want to remind you that during the webinar, you will be muted. Please use the questions area on your computer to type in your questions, and we'll answer those questions at the end of this presentation. If the audio on your computer is poor, please call the number on the invite to this webinar and listen on your phone. All NTCA webinars are available to watch at any time on the NTCA YouTube channel shortly after the webinars are presented. This will give you easy access to watch and or share all current and past programs at your convenience. I do want you to know there's hundreds of programs there. They're very educational. They can be business, they can be technical, they range from a wide range of topics. Please go and check it out. It's great. All right, I'm very excited to introduce today's presenter, Mike Little. He's a 50-year veteran of the ceramic tile industry. He's held management positions in both sales and operations during his career in the ceramic tile industry. In addition, he's worked for both manufacturers and distributors in various capacities. For the last 19 years, Mike has worked as a commercial architectural service representative with Custom Building Products. Mike's a member of the Construction Specification Institute. He's a construction documents technologist. He belongs to the Ceramic Tile Institute and is a certified tile consultant. Mike is also a professional affiliate with the Dallas chapter of the American Institute of Architects. He also is an industry partner with the American Society of Interior Designers. With a focus on sustainability, Mike is a lead AP. I do want to just mention one more thing. You heard 50-year veteran. He's been doing this since he was about 4. So just want to make sure that we all welcome him. So I'm trying to throw a little joke in there. So Mike, thank you for being here. Thank you for this presentation. Looking really forward to what you have to say.
Thanks, Jim. I appreciate it very much. And I like the aging you did. Before I get started, I do want to mention that I'm just recovering from a case of bronchitis. So if I cough or have to pause to take a drink of water, please bear with me. I'll be back, I promise. And before I get started in the actual presentation, I wanted to talk about what it was designed to do originally. And that is to help with the selection process to select the proper products and the proper installation methods for exterior tile installations. However, one of the things that I think is tremendously important, particularly on exterior wall installations, is that the installer be in touch with the designer or architect as early in the process as possible. I know that the NTCA is conducting presentations across the country with architects on this very subject to get those parties involved early. And it's extremely important when it comes to this particular topic. And I'll give you just one small example of why it's important. One of the things that we're really concerned about in tile installations in general, but in particular to exterior wall tile installations, is the deflection, how much movement is going to take place in that wall. So early on, the architect, designer, and the structural engineer are going to have to design that. Now, in most instances, the tile installer is not responsible for determining the deflection of the substrate that he's working on. He has to assume that it's meeting the proper codes. But that's one of the examples of where this can be a problem. For example, the International Building Code says for brittle surfaces, which tile is one of those, out of plane deflection for walls should be no more than L/240. However, the tile industry always recommends a deflection of L/360. And just to complicate things a little bit more, the National Stone Institute says if you're using a natural stone on a stud wall, either metal or wood, they need an L/720 deflection. So it not just becomes responsible to the designer to know which code he's applying, but also which material is going to be applied to that wall. That's just one of several considerations that need to go into that conversation with that specifying entity. So the sooner that those two parties can get together, the better and more successful that installation is going to be. Now, hold on just a sec. I'm having trouble moving my pardon me, Jim. I'm not getting my.
Are there little arrows down at the bottom, Mike?
I don't see them.
Click on your
No.
slide.
I don't see any little arrows. I just see my.
How about arrows on your keyboard?
Yeah, I'm trying those and they're not working either.
All right, everybody, we're gonna have Mike reload this. So can you get out of your presentation, Mike, and just come back?
Let me check. Hold on.
I'd try and tell some jokes here, but that isn't going to be good.
No. I may have to come right back into the meeting. I can't seem to get out of this.
Why don't you check out quick and just come right back in?
All right, we'll do.
I'll be waiting for you. Okay. Everybody, please be patient. This will take about 2 minutes. Sorry about this. For those of you just coming on, we're having a little technical difficulty and we will be back in seconds, even though it might be minutes, but hopefully it's only seconds. So. Mike, are you still there? There you go. All right, he's checked out. He'll check right back in now. Very sorry for this. It was working minutes ago. I hope everyone's having a great day. This will give you a couple minutes to close your eyes and rest. Get ready for the rest of the day. So. All right, Mike, let's go. I hope his computer didn't explode or something. So I want to remind everyone, we've got Total Solutions Plus coming up in Boston this October, and we've got TICE in January in Vegas, and we've got coverings coming up in Orlando in April. So Mike is back. We're going to make him a presenter. Are you there, Mike? Turn on your microphone. Mike, are you there? Your micro.
I'm here. Yep.
All right. Let's try again.
All right. All right, here we go. Sorry about that.
Can you move?
Yes. Can you see learning objectives?
Yes. All right.
Okay. So here's what we're going to try and accomplish during this presentation. We're going to try and help everyone understand how to select the proper products for exterior use, because it's going to be subjected to more extreme pressures than normal. We're going to talk about the different installation methods available for all of these different types of installations. And lastly, we're going to spend quite a bit of time on the challenges associated with exterior tile installations. And they are a lot of them. So let's get right into it. When it comes to product selection, we're going to be guided by the American National Standards specifications and the Tile Council of North America handbook. The porcelain tile, ceramic, mosaic, and quarry tile all have to meet A137.1 to be regarded as standard grade material. Gauged porcelain tile panels and slabs have to attain the ANSI A137.3. The National Stone Institute determines the specifications for dimensional stone to be installed on exteriors. And lastly, glass tile must meet the requirements of ANSI 137.2 to be considered adequate for installation on exterior applications. When it comes to the installation materials, these are the selections that are most important. Waterproofing membranes must meet ANSI 118.10. Tile mortar must meet ANSI 118.15. And the grout must meet ANSI 118.7. Sealant must meet all the requirements of EJ 171 in the Tile Council handbook. Now, I'm going to spend some time on each one of these later and tell you why these particular standards were selected for exterior applications. When we're looking at tile to be installed on an exterior, the first question that we need to get answered is this tile suitable for the application? In other words, is it going to stand up to the rigors of the thermal conditions, the freeze-thaw cycles? All of those questions need to be answered from the manufacturer. And even the backing can be a consideration on exterior tile installations. I know of a swimming pool installation where the backing was water soluble. Well, you can imagine how well that lasted in a submerged situation. So we have to ask all of the important questions to make sure we don't have problems down the line. Are the installations products going to be compatible with the intended surface materials? That's extremely important. We'll talk about that a little bit more when we get into the installation requirements. And finally, if it's a walk surface, does the tile selected have a suitable slip resistance or dynamic coefficient of friction? That's a tremendously important consideration considering how litigious our society has become. Also, we have to say, is the size appropriate to an exterior application? Now, on floors, on horizontal surfaces, it doesn't matter much, but on vertical surfaces, the codes have specific requirements. Stone can be no more than a ½ inch thick, can be no longer than 36 inches in the largest dimension, with not more than 720 square inches of facial dimension. The weight limit on stone is 15 pounds per square foot. Gauged porcelain panels are typically 1/8 of an inch to 1/4 of an inch thick. They can have a maximum size of 72 inches on one side. They have a 17.5 square foot maximum facial dimension, and they have a weight limit of 3.5 pounds. Standard thickness porcelain tiles typically range from about 1/4 of an inch to 5/8 of an inch thickness. They have a maximum size of 48 inches on any one side, a total of 9 square feet of facial dimension, and a 6 pound per square foot weight limit for those. So depending upon the type of product being installed, we have dimensional sizes that we have to stay within. When we talk about walk surfaces with tile, a lot of responsibility is given to the specifier. The specifier is the one who has to determine that the materials are appropriate for any specific project conditions, which takes into account the type of use, the traffic, the expected contaminants, the expected maintenance, the expected wear, and the manufacturer's guidelines and recommendations. That's a lot of responsibility. ANSI A326.3, the standard for hard surface materials for determining the dynamic coefficient of friction, was revised recently to help those who are selecting products make sure that they're getting the proper selection. So what they did is they divided the products into 5 categories. There's interior dry, interior wet plus, exterior wet, and oils and greases. Those are 5 different categories of products. And here's the criteria that's needed for us to determine which area of expertise it fits into. Interior dry has to have a 0.42 dry DCOF to be considered appropriate for that application. Interior wet has to be a 0.42 wet DCOF in order to be considered for that application. Or it could be manufacturer declared, meaning the manufacturer says this product will perform well in that particular situation. Now for the interior wet plus, the exterior wet, and the oils and greases, all of those need to be manufacturer declared. In other words, the manufacturer is going to tell you whether or not those products are appropriate for use in those particular situations. And to help you define what those situations might be, they've come up with these examples of work areas. Interior dry would be indoor shopping malls, hotel lobbies, office buildings, and showrooms. Interior wet, entry foyers, restrooms, grocery stores, and front of house dining areas. Interior wet plus are public showers, pools, locker rooms, and covered exterior areas. Exterior wet are pool decks, patios, walkways, and sidewalks. And oils and greases pertain primarily to automotive fluids found in service areas and back of the house fast food restaurants where they might have food prep areas with grills or fires that may add additional greases to the floor. So the manufacturer should tell you where in those categories their particular tiles fit. Now, something I want you to be aware of is that in 2020, IAPMO, the International Association of Plumbing and Mechanical Officials, adopted a new provision in their swimming pool, spa, and hot tub code. And this provision requires their decks, ramps, coping, and similar surfaces to have a minimum wet dynamic coefficient of friction of 0.42 if tested in accordance with ANSI A326.3. Now, in order to achieve that, they have a formula that they've developed where they can take the angle of slope in degrees and convert it into what's needed to increase the dynamic coefficient of friction on that slope to achieve what would be a 0.42 on a level surface. Now, quite frankly, I don't know what this formula means, but I've got a lot of very, very smart people in our technical labs back home, and they've made a cheat sheet for me where I can simply put in the angle of slope in degrees, and it will tell me what that required DCOF is. And as an example, the maximum slope that the ADA allows in any kind of circumstance is a 1 in 8 slope. That equates to a 7.13 angle of in degrees. If you plug 7.13 into that formula, you get a 0.58 DCOF. So in order to achieve that level surface equivalent of 0.42 on that slope, you would need a 0.58 DCOF material on that ramp. So and one of the reasons I bring this up in most of my presentations is that I've found over the years when someone comes up with a verifiable, duplicatable, objective way of measuring something like this, it's usually adopted by the other codes and the building systems like LEED, etc. And it wouldn't surprise me to see this same kind of verbiage appearing in some of the codes as we go further into it. And it's just nice to know what they're talking about ahead of time. I'm going to go through the exterior installations that are available to you. I'm not going to spend a lot of time on each particular installation method, but I will point out some of the things that I think are probably the most important to consider. The first one we're going to look at is an exterior floor. It's a bonded mortar bed. It achieves a service rating of extra heavy duty. And probably the most important consideration here is that it requires positive drainage below the slab. You'll see the crushed stone indicator underneath that drawing. What that means is if we don't use a waterproofing membrane, we want that moisture that accumulates on the surface and then penetrates down into that slab to have a way of exiting that installation quickly. A lot of times we don't know what the condition of the drainage is below the slab on grade. And that's an instance when that optional waterproofing membrane that's indicated by that red line on the drawing might be necessary, because that would stop the water intrusion from the top at that particular point, and it would never reach the slab below and would run off on a much more efficient way and leave that surface free of excess moisture. F102 is probably what we see most of out there, and that's a thin set application where we're adhering directly to the concrete that's existing. And again, the most important consideration here is the use of drainage underneath that slab. And the same conditions apply. If you're not sure that you've got positive drainage underneath that slab, then it's probably the time to use that optional waterproofing membrane to stop the water intrusion at that level. It makes it a much easier process to handle the water in that fashion. Roof decks and balconies. The first three of these installations are primarily for roof decks. I haven't seen them used much on balconies, but let's go through those and I'll point out some things as we go. F103 is a exterior roof, service rating of heavy duty, and it has a drainage layer. That drainage layer is crushed stone, again, 1/2 inch maximum size. And the most important aspects of this installation, and frankly, most installations on a horizontal level on an exterior, is the slope, to make sure that we get positive migration of that water off of the surface of the installation. We also need to make sure we have proper flashing. We need to make sure we're using reglix in the proper form, and that we have drip edges when needed. And as you can see, this is a reinforced mortar bed. The option is there for a waterproofing membrane. That's a belt and suspenders application. One of the most important considerations of this installation is to make sure that the weep holes remain open so that that moisture can get out through that system effectively. F103B is a variation on that first installation, and the only difference here is we're substituting the crushed stone for a drainage manufactured drainage mat. Lots of good brands out there on drainage mats, and they work very effectively. And again, the important considerations of the flashing, drip edges, and how that moisture is going to exit that installation. If you want the installation, if you want the moisture to stay close to the surface, again, the use of that optional waterproofing membrane is suggested. It just doesn't allow moisture penetration beyond that point, which I think is a good thing for most installations. There's also an alternative option and this isn't in the Tile Council handbook, but it is something that most major manufacturers will agree to. And that's where you're using a PMMA or a PUMA system for the roofing. And we can incorporate that into a successful tile installation. It simply requires a 2-coat system with a sand broadcast to the second coat until it achieves rejection. The criteria that we're going to use for is that being successful is the sand should be anchored to a minimum of 35% of the surface. When that happens, when we have that kind of broadcast sand embedded in that system, it provides excellent mechanical bond and can be used very successfully to tile over. We just make sure that we have sealants in the proper places, the proper flashing, and again, the proper exit for the moisture that's going to accumulate on the surface. Exterior floors and balcony decks, most of the time, are going to be installed using a thin set application, which is what you're looking at here. It can be done very successfully. I highly suggest the use of an optional waterproofing membrane in this type of installation to prevent any issues happening with moisture into the substrate itself. But again, the proper things to look for here are the slope, the minimum of 1/4 of an inch per foot, the reglet, and how the moisture is going to exit the installation at the end of the slope. Very straightforward installation and very successful. This can achieve a heavy duty rating as well. So it's going to stand up in lots of instances. As I discussed earlier, walls are some of the most difficult installations that we're going to come across when we do exterior tile work. And let's go through some of the installation methodologies that you can use. W201 is where we're installing a tile using a mortar bed on a masonry or concrete base. This is especially advisable when you have flatness concerns. Even on the walls, we still need to maintain that flatness of a maximum of 1/2 inch deformity in the substrate in 10 feet. So this will achieve an extra heavy duty rating. It's a very, very compressed installation. Typically the mortar bed is anywhere from 3/4 of an inch to 1.5 inches thick. It's a reinforced mortar bed, and it has a cleavage membrane, which kind of acts as a separator to allow for more movement to take place without doing any damage. It's an excellent method when you're doing large format tiles because it allows the installer to make his own substrate to his needs. He's not dependent upon the masonry and concrete that he's starting with. W202 is a thin set application where we're going to adhere directly to the exterior wall. I will tell you that in most cases, there's going to be some remediation necessary to achieve the flatness that's required for large format tiles nowadays. So that's a consideration in the design process of how much of an allowance that should be. And in this case, I highly recommend the use of the optional membrane to prevent, again, that water intrusion into the substrate that can cause us to have some difficulties down the road. And here's the one that's probably going to give us the most technical aspects to be aware of, and that's where we're using a stud wall on an exterior. Make sure that when you do this, you're using the proper products, and that starts with the backer board. The Tile Council in North America recognizes about 6 different types of backer board that can be used in tile installations. But on exterior walls, they limit that to cement backer boards. So make sure that you're using the proper backer board in this installation. In addition to that, you've got to have wall framing that has to adhere to ANSI A108.11 4.0. It has to make sure it has to do with the gauge of the steel studs, the deformity, the deflection, all of those criteria. Those need to be adhered to when doing an exterior wall installation of this type. The optional waterproofing membrane is here again an advisory thing to allow moisture not to penetrate into those studs, particularly if it's a wood stud, which can cause deterioration over a long period of time. And again, flashing is imperative, the proper flashing at the top and a proper exit for the moisture at the bottom of the design. Very, very important considerations. Pools. We don't do many pools. It's usually more of a specialized installation, but tile is available for pool selection. And quite frankly, if you've ever seen a glass tile pool lit up at night, you'll understand why it might be advisable. The pool considerations start with number one, it has to be a watertight concrete, shotcrete, or CMU pool tank. And probably the best installation that I can think of is a bonded mortar bed. This allows the contractor to make any changes to the surface that he needs to make the tile size that he's using adequate for that pool surface. It just gives him more flexibility in his workmanship, which is usually ends up in a better finished product. Now, we can use a thin set approach to a pool lining, but here again, there's probably going to be some remediation needed to get it to the flatness desired and to the curvature desired for the type and size of tile being used. And again, we need to start with a watertight concrete, shotcrete, or CMU pool tank in order to do this installation. If it's not a watertight, then we're talking about providing some waterproofing to that surface, and that's what this installation is, P602. And what you see here is a mortar bed that also incorporates an optional waterproofing membrane to provide some protection for that installation from that constant exposure to water that they're going to get. Water fountains are another tile option that can be very, very aesthetically pleasing, and it's a fairly easy installation at this point, given the liquid applied waterproofing materials we now have the option of using. This is a tile tub, a fountain, or a curb. It's a waterproofing membrane, and in this particular instance, the waterproofing membrane is not an option, it's a requirement. And as you see here, as it works down to the drain, one of the most important aspects of this is that crushed tile or stone to make sure that the weep holes function properly and aren't clogged at any particular time so that the water can evacuate that surface. And in this particular diagram, that purple line that indicates the waterproofing membrane, that's where that moisture penetration is going to stop, and it's going to direct it to those weep holes as you see diagrammed there. This is a curb using wood, again, with a waterproofing membrane that's a requirement. It just shows you the buildup. It's going to be a cement mortar installation, does not necessarily have to be reinforced, but it's another option that you have for going over a wood form to allow that to take the abuse that a constant submersion is going to have. This is a curb, and again, it's a waterproofing membrane that's not an option, but has to be employed, and a cement mortar bed, and again, making sure that the weep holes are open. Those are pretty consistent within all of these. So now we get down to the challenges and the difficulties that we're going to have in an exterior application, and what the products involved are going to have to do in order to perform well. We mentioned earlier on that an ANSI 118.15 mortar is recommended for this type of installation. And the reason for that is that in order to meet that ANSI 118.15 performance, they have to have more polymers involved in the mixture. The photograph that you see on the right is a highly magnified photograph of a polymer modified mortar, and that crystalline structure that you see there is the Portland cement and sand structure that happens That other stuff, that gooey looking stuff that you see stretched out there, is the polymers. And those polymers do a couple things for us. Number one, it makes it a more flexible mortar. Which is really important on exterior applications, because we're going to get deflection, we're going to get thermal changes, and that mortar is going to have to respond to that in some measure. A 118.15 mortar is designed to do that. It's got more flexibility, it's a stronger mortar, and it has a high polymer count to allow it to do that. I also mentioned earlier that an ANSI 118.7 grout, high performance cement grout, would be an excellent choice for an exterior application. And this is why. Rather than having a Portland cement and sand binder, they use a calcium aluminate binder in the ANSI 118.7. And it has a much higher polymer count than a standard cement grout does. The result of these changes creates a grout that, among its many other qualities, and it has a bunch, it does not allow efflorescence to migrate through the installation. So that if you have a porcelain tile, excuse me, if you have a porcelain tile and a 118.7 grout, the efflorescence has nowhere to build and to grow and to migrate through. So it's in essence an efflorescence-free installation at that point. Probably the most difficult challenge that we have to face with exterior installations is the weather. The design must accommodate water intrusion, freeze-thaw effects, extreme heat, and thermal cycling. Those are all characteristics of exterior tile installations that aren't usually found in any other situation. So when we have water evacuation, it's always the key factor in exterior walk surfaces. We don't want water to remain on the surface, as you see in this photograph. That's a danger. It's a slip resistance danger, and it's also not doing any good to the interior of that installation. It's soaking in, and it has nowhere to go. So that horizontal surface needs to be kept clean of any kind of excess moisture. And the faster and more effectively that water drains from a tiled surface, the less risk you're going to have of two conditions. Number one is freeze-thaw effects, and number two is efflorescence. Now, the photograph that you're looking at is an extreme example of where the efflorescence was not taken into account. They didn't have proper evacuation of the water from the surface. It bled into the substrate, and the salts and minerals in that concrete substrate started to come out and weep when the moisture went through that installation and out over the tile. And the consequence is that white chalky looking stuff that you see there. Now, we can clean that with a sulfamic acid solution and probably getting it pretty close to its original look, but we didn't stop the conditions that caused it to happen in the first place. It was designed improperly. I can promise you that there was no waterproofing membrane used in that particular installation. And to be successful, the assembly has to take into account the space that it's being used. The pitch of 1/4 of an inch per foot, obviously it can't be done in one section if it's a very, very long section. So it has to be done in smaller units, and it's extremely important to the success and safety of the final installation that be accounted for during the design and installation process. Tile patterns like the Versailles or a basket weave pattern will slow down that water flow just by the sake of the grout joints. So it will take longer for those patterns to drain than it would, maybe some of the other more linear patterns. And in addition, the surface texture of the tile itself can also make a big difference in how effectively that water drains. These are all minor considerations that go into the product selection process that can have a huge impact on the final installation. And then we come to the number one cause of most failures in exterior applications, and that's movement joints. Most of the time when I talk to architects about exterior wall installations, there's a hesitancy there because they've experienced difficulties in the past. And some of those difficulties have occurred because of the trade that was assigned to do the work. In a lot of cases, masons, because they were familiar with exteriors, were allowed to do tile finishes, and the problem becomes what kind of materials are they using? The strongest bonding material in the masonry trade has a bonding requirement of about 50 psi. Well, if you oppose that to a 118.15 mortar that has to have a minimum bonding strength of 400 psi, you can see the extreme differences. And that's because masons were used to compressive strength and not necessarily bonding strength. So it's important to know which trade is going to be doing this and that they use the proper bonding material. And then once they do that, they also have to make sure that they're putting in the movement joints that are going to be required in an exterior application, because if they don't, you're going to get the effects that you see on the building in the photograph. These movement joints must take place no more than every 10 to 12 feet in any direction. And that's specified by EJ 171 in the Tile Council Handbook. And here's a diagram of a movement joint where you've got a compressive material, and you can see that it goes all the way down to the substrate. You've got a compressive material, you've got the sealant, and you've got the joint that'll allow two different materials to move without showing damage to the installation. And the minimum size movement joint on an exterior installation, whether it's horizontal or vertical, is 3/8 of an inch. That's a minimum, and it has to be duplicated every 10 to 12 feet. So movement joints, here's an example of EJ 171 expansion joint, which is typical. This one's on a horizontal surface, and as you can see, it's got a compressible backup material. It's got the backer rod, and then it's got the sealant. And all of the requirements for EJ 171 are there, including the types of materials that can be used for the sealant, as well as their performance characteristics. So following EJ 171 will keep you out of trouble when it comes to movement joints. And it's interesting to note here that it's the designer or architect's responsibility to show you where those movement joints should go. But often they aren't aware of the frequency that's required. And that's one of the reasons that, for example, these NTCA conferences across the country, where they're talking to the architects and designers about that cooperation between those trades. That's why it's so important, because they need to know how to express to you how these movement joints should go. And if they don't show any movement joints, and that does happen on drawings that I've seen, that you need to be aware of the use and inform them of what should be taking place to make sure that installation lasts as long as it's supposed to be designed for. So just one of those things where the communication between the architect, the designer, and the installer is absolutely critical to make sure we get those movement joints correct. I'm running out of voice at about the same time I ran out of program, so that's good, Jim.
Good job. Good job. I appreciate the great information, Mike, and I want to thank everyone for staying with us, because we've gone through a little bit of a problem here, and we do have some questions to go through. Mike, I'm going to ask you a couple of questions, and I think the first two are pretty simple. You mentioned facial dimensions in the very beginning, and can you explain that to our attendees, what facial dimensions and how that works, what it is?
Well, facial dimension is the size of the tile. You know, it's the length, you know, times the width, you know, multiplied. So if you've got uh, a 10 inch by 12 inch tile, you've got 120 square inches. That's the facial dimension. And that's how the codes, you know, originally the codes were more concerned with the weight of the material than they were the size of the material. What changed the game and made the codes change, I think it was in 2020 that the changes occurred, is the inclusion of the gauged porcelain panels, because they exceeded the size dimensions considerably, but they were well under the weight considerations. So that's when they decided they had to break those dimensions out specific to the type of material that's being installed. And I'd be happy to send anybody the list of requirements for the different types. If they'll just, you know, just send me an email and I'll be happy to delineate those for you.
Attendees, tomorrow you'll receive an email thanking you for attending. And if you want to reply back and ask any questions about this, I'll make sure Mike gets it and he answers those questions. That was great, Mike. The next one is fairly similar.
Okay.
We have an attendee asking, what is DCOF? I know you went through that pretty well and you probably answered it after this, but why don't we just go through that real quick?
Okay. The original measurement for coefficient of friction was SCOF, static coefficient of friction, and that's what was originally designated in the ADA Act. I think it was in 1970. But the problem with that particular methodology is that it wasn't duplicatable. The testing system for that was not very sophisticated. They'd take a piece of neoprene or leather material, they'd put a weight on it, they'd put a dynamometer on it, and they'd measure the amount of force needed to get that to move from a standstill. Well, depending on who was doing the pulling, you know, you could get variations in that reading. And so it often ended up as a range of coefficient of friction, which was not really enforceable. Reagan Electronics developed a machine called a BOT 3000 that measures coefficient of friction based on a dynamic or moving methodology. And it's duplicatable. You simply put the machine on the surface to be measured, you press a button and it measures it. Because of the effectiveness of this machine, the manufacturers agreed to put that into a specification. Originally, the hard surface standard, ANSI, the one that we know as ANSI A326.3, started out as a standard just for tile installation. ANSI saw that it was measurable, saw that it was objective, and decided to incorporate that to include all hard surface materials because of its effectiveness. And it just gives you a more accurate representation of what that coefficient of friction really is based on the measurements.
Excellent. This is to our audience, Vitali. I'm going to ask this next question. If I don't ask it correctly, please send me a clarifying question and I'll see if we can get to it. But he's asking, Mike, what if he installs movement joints every 4 feet, but only 1/8 of an inch of a joint? Does that make sense, what he's asking?
It does make sense.
Okay.
I do know that in some cases, particularly when you're using the larger panels, it's almost impossible to achieve an aesthetic that's pleasing with the larger panels when you've got a big honking movement joints there. Okay, so I do know of instances where they've decided with these large panels to caulk the entire installation rather than grout it using a silicone or a urethane caulking material. And I would say that as long as the total of the compressible material equals that 3/8 of an inch requirement, that should be sufficient, and it could be broken down into smaller increments.
Great, great. I learned something. I love it. Mike, who determines the expected movement? Would that be the architect?
It's up to the architect and structural engineer to determine the deflection and the movement of the wall, which, that's another critical area in design. There's a P delta effect, which takes into account all the kind of conditions that could affect a wall. All of those considerations have to be done by the design professional.
Great. James, if I ask this question and it's not correct, please reply. But Mike, what it says is, can you ask about they're asking about your experience with the ProRail system. Okay.
I don't have a lot of experience with the ProRail system. I do know that it's been used successfully on many exterior applications. I just don't have a lot of personal experience with it.
Well, make sure, James, you reach out to us when you get the email, and maybe we can do a little research and find out something. Thank you. So the next question, Mike, what is the maximum tile size for exterior adhered tile?
Well, it goes back to those, what type of tile are we talking about? If it's a standard porcelain tile, the dimensions are maximum of 5/8 of an inch thick, 9 pounds per foot. 9 square feet of maximum facial dimension. That'd be a 3x3 tile, in essence, or something the equivalent. And a maximum weight of 6 pounds per foot. That's what the codes say. Now, I will tell you this, that even when the codes were more restrictive, and the larger tiles came out, I don't know of any architect that asked for a code variance that did not receive it. Because when you think about natural stone and how heavy natural stone can be in the same application, most of the porcelain tiles, even the thicker porcelain tiles, don't reach the weight of the natural stones. So I know of a number of instances where code variations were granted when they wanted to use something larger than the code specifically allowed.
Great. All right. I hope that answers, Mike. Next one is there a DCOF requirement to meet ADA?
The only ADA requirement is the same one. It's only relatable to horizontal surfaces right now, and that's the 0.42 DCOF, dry or wet.
All right.
They do not have one for ramps yet. That's why I think that IAPMO standard will be important to us in the future.
All right, great. This one's on weep holes, Mike. Weep holes always fail. Just ask my plumber. Is there any chance that there can be a disclaimer added in construction standards that will qualify that? The stone tile contractor always is the first person they blame when the weep holes fail.
I understand that question completely. My suggestion to you in that particular instance is to try and get them to change to a bonding flange configuration rather than the traditional drain assembly. The bonding flange drain assembly has the weep holes on top of the assembly as opposed to on the bottom of the assembly. And there's a screening agent on most of the brands out there that allows the moisture to evacuate very effectively. I can send a diagram that would indicate that, and help solve that problem for them. And it's a very easy change of drain systems.
Okay. Was the ADA ramp rise run dimensions given mainly for ramps into swimming pools?
No.
Otherwise, aren't standards ADA 112 or is it 1.8 new?
It's 112, or it can be 1 and 8 for special considerations like an existing building.
Okay.
But new, it's 1 and 12.
And is it mainly for swimming pools or anything?
No, it's on any incline that might be navigated by a handicapped individual.
Perfect. Great. All right. Last month, we had a whole webinar on this, but what is latex leaching? And Mike, if you want to just go to NTCA's YouTube page, you can watch a whole 45-minute
Yep.
program on what is latex leaching. So
Yeah. Yep. It happens, it
give them a
happens.
quick run through what it is, just a real quick one, Mike.
Well, it's when an installation with latex experiences a lot of excess water. Sometimes it emulsifies some of that latex, and it kind of acts like a migrant effect and goes to the surface of the tile. That's a very quick explanation.
Sure, sure. Let's see here. What's this one? All right. Does Custom recommend polyblend grout for exterior installations? This person's concerned about efflorescence.
We've used polyblend grout successfully for decades, but we recommend the high performance cement grout on exteriors in particular because of the effect that it has on efflorescence. It just doesn't allow it to transmit. It's a safety factor, and it's you're probably looking at, I don't know, an additional nickel per square foot cost.
Okay.
It's highly recommended on exterior applications.
All right. Excellent. Next question, Mike. What if you don't have architect or engineer? You're doing just outside, a wall outside. Who decides the movement joint and the extension?
Theoretically, there should be some kind of engineer or architect involved, but if you're just doing it on your own, then you're going to have to incorporate them yourself. And as
what I would
long as
say,
you
Mike,
follow
is the TCNA handbook has guidelines for that, and if you
yes, it
follow
does.
those guidelines, you
Yes, it does.
should be fine.
Yep.
Yep. So that's what I would do. Follow the TCNA handbook guidelines, and you can reach out to TCNA for a handbook. And if you're a member of the NTCA, you get the updated handbook every year, a brand new updated handbook. So
There you go.
all right, next one. Architects try to never do their jobs to design and place the expansion joints. How do we make them do their duty to design and place the joints?
If I had an answer to that one, I'd be a rich man.
Yeah,
I at every presentation I give, I stress the need for their responsibilities, when it comes to deflection and movement joints. It's often overlooked, and I quite frankly, I don't know how to do it other than education.
yeah. I mean, all we can do is keep going out there, and I think Mike mentioned just minutes ago about the training that NTCA is doing with architects and designers, talking with contractors and trying to work together so designers and architects really understand these kind of questions and how to address them and how important it is. So we're going to keep doing our part, but I know if I'm a contractor, I would just say, you need to, I would talk to the builder or the homeowner or whatever, or that architect, and just say, you need to make this decision. It's not my decision. So
Exactly.
and I would show them in the TCNA handbook, I would show them where it states that is the Bible of, so the Bible of installation. So definitely, Mickey, I'm sorry, that isn't the greatest answer, but it's one of the most difficult things in our industry is getting those expansion joints, movement joints located and where they should be.
No doubt.
All right. So Crystal, you asking for a copy of this presentation as I sent. This will be, send me an email tomorrow asking for this, and I will connect you with the YouTube page and where you can watch this and share this with anyone you'd like. Thanks, Crystal. All right. James, same thing for you. All right. Ellen, if you want to send me your question tomorrow, I'll make sure Mike can send you the drain system, bonding flange system, et cetera, et cetera. So thank you. The YouTube channel, if you go to the NTCA's website, which is tile-assn.com, and click on the little YouTube at the very top, there's a little YouTube in red, YouTube thing or whatever there, a little arrow that YouTube uses. You can click on that, it'll take you right there. Otherwise, it's the NTCA YouTube channel. All right, here's one. What grout will be recommended for pool areas?
Again, a high performance cement grout works the best.
Did you
That's the
notice he didn't say anything
118.7.
about Custom Buildings product? Because I asked him not to make it a sales pitch here, but he's great. A high quality grout, cement grout is great. All right, what's next here?
Prism is our go-to high performance cement grout.
I gave you an opening, Mike. There you go.
Thank you.
All right. So Vitaly, you said you're an NTC member. Thanks so much. He appreciated everything, so that's great. All right. So Ellen, I get it. Please make these IDCEC certified so you can get more designers out. In 2025, I am going to be working on more IDCEC and AIA programs. I do think they're important, and I know Mike probably could have had this as he shows a continuing education program. It's just that I try to give these manufacturers a little leeway as opposed to AIA, but I can ask for those, and I will definitely do that, Ellen. Thank you. So we answered a question for Mickey on movement joints and expansion joints, and he says he does have the handbook, and he says that if the architect does not do it, then it does not relieve the contractor of the responsibility. That is true.
That is true.
Can we give Mickey a better answer?
Well, I think when it's not included in his instructions and in the drawings or whatever, then he needs to submit it and says, "Here's what I'm planning to do. Do you approve?"
Get a written okay.
Get a written authorization. You betcha.
Yeah, that's really good.
The least they can do is approve your recommendation.
All right, Mike, we have gone through all of the questions. I want to thank you for the great information, the great presentation. I want to thank all of you that attended today and those that stayed through the end. Thank you. We'll have an invite will be coming out to you soon for the next webinar. The next webinar will be presented by Schluter on September 12th. So we look forward to that. Mike, thank you very much. Everybody have a great weekend.
Enjoyed it.